Good morning, everyone. I, Amita from Physics Department, delighted to welcome you all to the third day of this enriching faculty development program on emerging topics in applied science 2025. Physics is not just a subject confined to textbooks and laboratories. It is the very foundation of the world we experience every day. From the motion of vehicles to the technology behind smartphones, from the forces at play in sports to the principles governing weather patterns, physics is everywhere. Yes, all of you guessed right. Today's session subject is physics, and the topic is unmasking the physics around us. It aims to bridge the gap between theoretical concepts and real world applications, helping us see the unseen principles that shape our daily lives. By exploring these fundamental ideas, educators and researchers can enhance their teaching methodologies and inspire students to develop a deeper appreciation for the role of physics in shaping the modern world. Let us embark on this exciting journey of discovery and uncover hidden wonders of physics all around us. First and foremost, I extend a warm welcome and heartfelt welcome to our esteemed speaker, Dr. Suryanarayana K. A heartfelt welcome to all the offline, online participants joining us from various institutions. Also, to esteemed conveners, coordinators, and faculty members. Today's session is dedicated to exploring the fascinating world of physics. And we are honored to have with us an eminent scholar and educator, Dr. Suryanarayana K. Sir is a distinguished professor and head of physics department, Srinivas Institute of Technology, Mangalore. With an illustrious academic journey that began with an MSc in physics in 1990, he earned his PhD from Mangalore University in 1999. His vast experience of 34 years in teaching and 18 years in research has significantly contributed to the field of crystal growth and characterization. Throughout his career, Sir has guided research scholars, published over 13 research papers in reputed national and international journals, authored 4 books and 2 book chapters, and participated in 60 plus seminars and workshops. His role as a PhD advisor, resource person, and reviewer for international journals highlights his dedication to advancing physics education. Additionally, his contributions extend beyond academia as he has actively guided high school students in science projects and helped over 2,500 students earn an energy literacy training certificate from the Energy Swaraj Foundation. Sir has also demonstrated his commitment to academic excellence and professional development by successfully completing 4 certificate courses, and they are accreditation and outcome-based learning, accreditation for undergraduate engineering programs, teaching and learning in general programs, National Education Policy 2020 Professional Development Program. It is indeed a privilege to have him with us today to share his insights and expertise. Let us take this opportunity to actively engage, ask questions, and gain valuable perspectives from his wealth of knowledge. With that, I wholeheartedly welcome Sir Dr. Suryanarayana K and invite him to lead today's session. Wishing you all a productive and insightful learning experience. Over to you, sir.
Okay. Thank you, madam, for good introduction. With that introduction, I think all the participants, you came to know outline of today's session. See, unmasking the physics around us. This is today's topic. See, in our everyday life, we are observing different phenomena. We are seeing different objects. We are doing so many works. Everywhere there is a physics. Physics principle is there. Physics theory is there. Sometimes it is noticed from us. Sometimes we are not noticing it. But in our day-to-day life, in our classwork, it is better to mention such day-to-day informations about the physics throughout our class works. That helps the students to understand the physics and to get interest on the physics. On this basis, I taken this topic, unmasking the physics around us. See, here this slide shows physics. Where are physics? Everywhere. Light, atoms, sound, heat, friction, different branches of physics. Gravity, magnetism, inertia, force, electricity. See, like this, we may extend so many. See, as all of us we know, in universe, energy is only in two forms, either in the form of mass or radiation. See, therefore, each mass, there is some energy. Or see, light, radiation, heat, radiation, they're also energy. Therefore, any form of energy is in two forms. Then, however, we are talking about kinetic energy, potential energy, nuclear energy. See, everywhere there is a mass and radiation that comes into picture. What is the need of understanding this physics in everyday life? I will uh, I collected a few points about this. See, understanding the natural world. Physics explains the fundamental phenomena like gravity, motion, energy, and heat transfer, etc. By understanding these, students can appreciate how the world works, from why the sky is blue to how a car moves. Say like this. Practical problem solving. Understanding friction helps when walking on slippery surfaces. This is one of the example which I am giving. Say practical problem solving, how we can understand it. Knowing about electricity makes it easier to use household appliances safely. Developing critical thinking skills. Physics encourages analytical thinking and problem solving by asking students to analyze situations, make predictions, and apply logical reasoning. Technological applications. Everyday gadgets like a smartphone. See, now we know without food we can live, but without phone we cannot live. That is the situation for us or for students. Therefore, like smartphones, microwaves, and cars rely on principles of physics. Understanding these principles helps students appreciate technology and use it more effectively. Environmental awareness. Physics is crucial for understanding environmental challenges such as climate change, renewable energy, pollution. Thus, students can make informed decisions about sustainability by understanding energy transfer and conservation, etc. Therefore, in the environmental awareness is also very, very important. How we can save the energy, how we can produce the renewable energy. All these informations is very, very important for the students. See, on this basis, as madam, while during my introduction, she told I made around more than 2,500 students to go through an certificate course on energy literacy under Energy Swaraj Foundation. See, by which the students can understand something about how I can save the energy, at least when they are going out of their room or out of their classroom. They can switch off their phone, switch off the fan in that room, by which they can save the energy. Such a certificate course, if anyone is interested, I will send the link. You can also do that certificate course. Foundation for future careers. Many fields like engineering, medicine, architecture, and aviation require a solid understanding of physics. As you know, any engineering branch, for that basic science is very, very important. Early exposure can ignite interest and provide a foundation for their careers. Personal safety. Some of the examples I mentioned: wearing seat belts reduces injury risk during car accidents due to an understanding of inertia. See, if we understand this, the rule is not needed. Government, there is no need to tell you have to wear the seat belt. We ourselves, we can understand, we can wear the seat belts. Knowing about electrical circuits can prevent accidents at home. These are some of the examples which I mentioned for about the personal safety, where the physics principles are there. Fostering a curiosity and innovation. Learning how simple principles lead to complex systems can inspire curiosity and innovation. Students might become inventors or researchers solving real world problems. See, nowadays, any research work that needs some output, which can give some output for the real world problems, that is very important nowadays. Enhancing decision making, from selecting energy efficient appliances to understanding how weather pattern work. Physics knowledge aids in making better personal and social decisions. See, these are the some points which I collected, where we need physics, what is the importance of physics in our real world. See here, physics helps us to understand the world around us. Some of the points I mentioned: electricity, power our homes, gadgets, and industries; medical imaging like X rays, radioisotope, nuclear magnetic, NMR, etc. etc. Inertia, the tendency of objects to stay in motion or at rest unless a force changes their velocity. Seat belts, that is example which I will explain in my next slides. Thermodynamics, acoustics, gravity, electromagnetism, momentum, driving a car, kicking a football, using a phone. See, in home appliances, see, if we go to our kitchen, so many utensils we are using, so many works we are doing. See, there everywhere there is a physics, a glowing of gas or heating, everywhere there is a physics. See, like this electric bulbs and lights, fans and air conditioners, refrigerators, microwaves, ovens, washing machines, television and monitors, speakers, mobile phones, vacuum cleaners, electric irons, toasters, water heaters, geysers, blenders, mixers, hair dryers, electric kettles. See, like this, we may list so many things. I listed a few. I may collect so many other things. See, everywhere, electric kettles, heat transfer and energy conversion, air dryers, electromagnetic energy and fluid dynamics. See, like this, in each and every home appliance or device, there is some physics. See, we'll discuss a few appliances or a few principles which we are using in day-to-day life. See, as we know, electricity. Hydroelectric project is a method in which water is used to generate electricity, we know. The mechanical energy of the water is converted into electrical energy using dynamo. Actually, not only mechanical energy, actually initially potential energy. See, in the dam there is a water. That is the collection of water means there is a lot of potential energy. That when water that falls from there to the down, that energy is converted into heat. See, therefore, if we go through this figure, see water reservoir of the dam. See here, the potential energy is there. That when water flows, flowing water, kinetic energy, and hydro power plants. See here, there is a turbine. When that turbine rotates, it rotates the generator that produces the electricity. Thus, see in each point here, potential energy, kinetic energy, that is physics, turbine rotation, physics, and generator, physics. Next, about batteries. Here, physics and chemistry both are there. See now, the mobile phone, the technique of mobile phone developed this much. That is mainly because of this battery storage, a small size, lot of energy we can produce. Because of that reason, we can carry the mobile from in our pocket. Otherwise, it's very difficult to carry the mobile because the weight of the mobile or size of the mobile, that it mainly depends on this battery. See, as we know, in 2019, the Nobel Prize in Chemistry was awarded to John B. Goodenough and M. Stanley Wettingham and Akira Yoshino for their work on lithium-ion batteries, which is the base for the battery which we are using in the mobile. See, electric bulbs and LED lights, as we know, principle of optics and electricity which they are using in this conversion of electric energy into light energy. See there, initially incandescent bulb, then CFL. Now we are using LED bulb. See everywhere same thing. We are converting electric energy into, the light energy into electric energy, electrical energy into light energy. Even in the oil lamp, there is a physics, surface tension. That comes in the oil lamp also. See next, generally using sewing machine. Now electrical sewing machine was in use, but in this sewing machine, as we know, see here we are pushing this motion imparted here, a big wheel and then a small wheel. See, as we know, the equation for the rotation of the wheels, W1 into R1 equal to W2 into R2. W1 and W2 are the velocity of the two wheels. R1 and R2 are the radius. See, therefore, if I rotate this bigger wheel, this smaller wheel is connected to this bigger wheel through the rope, through the belt. When this bigger wheel does one rotation, here number of rotation is more, therefore the velocity is more. See, that is related with this equation. See, therefore, when a bigger wheel is connected to a smaller wheel through a belt, the velocity increases, the angular velocity increases. Therefore, the mechanical work which we need to use, that becomes less. See, that is a physics in this sewing machine. There is no need to go out. Inside our body itself, there is a physics. Physics is also applied in our body due to electrical signals which carry the sensation to mind. We are able to see, listen, or to feel the objects. See, the sensors, the design of sensor is actually on this basis. Next, as we know, 3 Newton's laws. Newton's law of motion. In everyday life, there's a lot of application of this Newton's law of motion. We walk fast, run, jogging, jumping. All these or any type of motion is associated with the Newton's law of motion. As we know, the first law of motion, an object at rest stays at rest unless an external unbalanced force acts on it. See, an object at rest will remain at rest if any volleyball, if it is there, only if somebody kicked it, or if air blows, or if we throw some stone to that ball. See, like this, if some external force if we apply, then only that ball moves. An object in motion will continue with the constant speed and direction unless external force is there. See here, if I kick one ball, if that ball falls to the wall, then only it will stop. See, therefore, Newton's law, first law, that applies in any process of this volleyball or cricket or anything. See, during walking, physics is involved even in our walking. While we have to walk in a park on a tar road, or we have to a good grip without slipping because of a sort of roughness or resistance between the soles of our shoes and the surface of the road. This resistance which is responsible for the grip is called friction traction. See, therefore, while selecting the shoe or while selecting the chappal, we are checking how much grip is there in that shoe. When that grip becomes less, then there is a possibility of a slippery. See, same thing is there in this car tires also. In while selecting the car tire also, we are checking that grip. Car seat belt. When you tighten your car seat belt, it works on the concept of inertia. In case of a car collision, your seat belt helps prevent your body from moving in forward direction. See, if we remember this, without any rules, we can wear the car belt. Seat belt. See, moving vehicle, if and jumping passenger. See, when vehicle moves, if we jump, then definitely we will fall. But if we jump in certain direction, there is a possibility of without any problem we can jump from the vehicle. When the passenger jumps out of the fast moving vehicle, his feet will come to rest on touching the ground, whereas the upper part of his body continues to move forward due to the inertia of motion. As a result, if he does not run forward, he will fall with his face in downwards direction. See, therefore, when a person jumps from the moving vehicle, he has to move along the vehicle. If he not moved along the vehicle, then there is a possibility of falling. Therefore, when a vehicle becomes slow, if we are jumping down from the vehicle, we have to take care about this. Newton's second law of motion, F equal to ma. If you use the same force to push a truck and push a car, the car will have more acceleration than the truck because of the car has less mass. See, if there is a truck, same person, if he pushes, then he has to apply more force because of the mass, heavy mass. That is Newton's second law of motion, by which we can understand. See, same thing. Say in bus, any bus stand or in anywhere, if we are pulling the luggage or pushing the luggage, when luggage is not there, I can pull or push the cart very easily. But when there is a luggage, I have to apply more force. Again, Newton's second law comes into picture there. Newton's third law of motion. When we jump a small rowing boat into water, you will push yourself forward towards the water. The same force you use to push forward will make the boat move backwards. Say from the boat, If I jump, then this boat goes backside when we are going forward. See, therefore, when we are jumping from any moving boat, we have to take care. There, Newton's third law comes into picture. While taking the food also, there is a physics comes into picture. As we know, when we eat food, the chemical energy of the food is being converted into mechanical energy. There is energy conversion. Food is the mass. That mass is converted into some other form of energy. And why, when we are eating the food, the moving part, there is a kinetic energy and there is a friction. If we are eating the hard food, then friction is more. Then sometimes we have to take the water with the food to decrease the that friction. So all these, therefore, even while eating the food also, physics comes into picture. See, nowadays mobile, the previously there was telephone. In that also there is a physics. Speakers, vocal cords, when we speak, audible sound waves are produced that propagate toward the phone microphone. The microphone will respond to the sound waves and convert mechanical energy into electrical energy. And that electrical energy moves through the transmitting line. And finally, the receiver receives it. That's electrical signal is converted into sound wave again. Therefore, throughout the path, there is a physics. Headphones, concepts of magnetism and sound waves comes into picture in the headphone. Wireless earbuds. See, nowadays the headphones is gone. Now earbuds came into picture. Here, device connected into the Bluetooth network communicate with each other using ultra high frequency radio waves. These are electromagnetic waves with the frequencies around 2.4 gigahertz. That ultra high frequency waves of different frequencies are used in microwave ovens, GPS system, and many other devices. Physics in cell phones, as we know, there also, see, in the touch screen or anywhere, there is a physics. And the mobile network, there also physics comes into picture. Communication physics comes into picture. Physics in nuclear power plants. See, as I already mentioned, the energy is either in the form of mass or in the form of radiation. See, nuclear power plant, the mass is converted into energy. Here, E equal to mc square, the Einstein's mass energy equation, that comes into picture in this nuclear power plants. Energy conversion of mass into energy. As I already mentioned, in the phone or even the internet. Internet in layman language is nothing but a group of data which are invisible in nature but can be seen in computers. Internet is a grid of digital and analog signals which are modulated and demodulated into each other using a modem. Internet come under wave mechanics because internet is motion of data in the form of waves. As we know, we can collect any information, so many informations I collected from the internet here uh, to prepare my slide. See, there also physics comes into picture. Say, any slide which I am putting here, you are seeing through your eye, working of eye, there are also physics. However, biology is there. Biology peoples will explain more about eye, but what is physics in this mobile, sorry, in the eye? See, the camera, I can compare the camera with the eye. Here one object, the light rays comes from the object that goes through the lens, it falls on the film of the camera where it displays the picture. Similarly, in our eye, the light from the object comes and there is a lens, and on the retina, the image is developed. See, therefore, see the camera and I can compare this both where there is a physics. Therefore, this is the analogy I can give for this camera. Ear. What I am talking, you are hearing. Again, through the internet, this information passes through your speaker, you are hearing, but in that ear, through which we can hear, there are also physics that involves the conversion of sound waves into electrical impulses that the brain interprets as sound. This process involves the interaction of the ear parts, including the outer ear, middle ear, and the inner ear. You see, in all case, there is physics. The sound wave, conversion of sound wave into electrical pulses. That electric pulses again sensed by our mind and our brain, and then it is converted into the response signals. Camera lens, as I already explained while explaining the eye. Alarm clock. See, morning, to wake up, we need alarm. Again, in that there is a physics. When that alarm rings, it produces the sound wave. That sound wave is transmitted, and we are hearing that sound wave through our ear, by which we may wake up. Therefore, to wake up morning, we need physics. Steam iron. After wake up, we have to dress. We have to go to our office. We have to go to our college. Again, we have to iron our cloth. There also physics. Their temperature comes, steam comes, thermodynamics, that principle comes. The foremost principle of physics used in the steam iron, heating effect of current. Therefore, thermodynamics of physics comes into picture in that steam iron. Yeah, once we reach our office, reach our college, to write, we need pen. Again, in that pen, we are using the physics principle. The concept of gravity comes into play. As our pen moves across the paper, the ball turns and gravity forces the ink down onto the top of the ball where it is transferred onto the paper. Again, when it is transferred into the paper, friction comes into picture. See, therefore, during writing, again, there is physics involved in the pen also. For the lunch, we need food. That food can be cooked in the pressure cooker. There are also physics. As we know, a pressure cooker uses a heat source to increase water temperature above 100 degrees C. We know boiling water, temperature of water is 100 degrees C, causing saturated steam to build up in the range. This high pressure condition continues as long as there is a liquid inside and no holes in the lid. Therefore, we may reach the temperature up to 121 degrees C instead of 100 degrees Celsius. This higher boiling point enables the foods to reach a cooking temperature that would not be possible in an ordinary pot on the top of the stove. In some cases, these are internal temperature above 98 degrees C. The trapped steam also cooks the food faster by conducting the heat more efficiently throughout the cooker. So therefore, in our kitchen also there is a physics. Similarly, I think we heard about the China dish, where the half cooked food we can keep inside that China pot, and if we close it and if we keep it for half an hour and 1 hour, it boils. Therefore, we may reduce the loss of the fuel. Physics in microwave oven. A microwave oven or simply microwave is an electric oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. This induces the polar molecules in the food to vibrate and produce thermal energy in a process known as dielectric heating. See, therefore, when we are explaining about the dielectric materials, we may mention this example. See, dielectric heating and why we are using microwave. The dielectric heating, the production of energy, the heat energy in microwave range is more. Because of that reason, they are using this microwave. Therefore, microwave ovens heat foods quickly and efficiently because excitation is fairly uniform in the over 25 to 38 mm. A homogeneous high water content food item. Therefore, the heat produced by the food itself makes the heat to boil. Or we may cook the heat produced by the food itself. There also physics comes into picture. If we come to the modern communication system, again, Einstein's theory of relativity, that comes into picture there. Physics is all relative, not only physics, our life itself the relative. This theme resonates through Einstein's special and general theory of relativity. Einstein's work is crucially important to GPS in your phone, for example. It takes radio signals from several satellites orbiting the Earth and calculates our location accurate to several centimeters. Because the speed and height of the satellites alters the signal very slightly, the smartphone adjusts the results using Einstein's theories. Without a helping hand from relativity, GPS would be far less accurate or useful. See, when Einstein uh, developed this theory of relativity, so many scientists questioned, according to the documents, why? What is the use of this relativity? See, now this modern communication system actually depends on this Einstein's theory of relativity. Actually, one history says Einstein got the Nobel Prize for photoelectric explanation of his explanation on photoelectric effect. They are not in position. Actually, they are interested to give the uh, Nobel Prize for his theory of relativity, but there is no application. Only for the application inventions they may give the Nobel Prize. At that time, they don't know the application of this importance of this Einstein's theory of relativity. But now the modern communication system uses that theory of relativity. That GPS, where, as I already explained, there is physics. Yeah. Now, see, in between this modern communication system and the old communication system, OFC came into picture, optical fiber communication. OFC cables, telecommunication is mainly on the basis of this optical fiber communication. See, there also physics comes into picture, but the lifetime of that is very less because of this uh, lifetime of that uh, application of optical fiber, that is very less because of this modern communication system. But still, in that OFC communication system also, there is physics, as we know. And if we go towards the agriculture, from the overhead tank, see, generally there is a power problem in the villages. Therefore, when we are free, we cannot run the motor, we cannot run the pump to spray the water to the agriculture land. Therefore, we have to stock the water in overhead tank. From there, we may make it to float to our land or our field, areca or paddy, whatever may be the thing. See, therefore, twice we have to use the motor or pump power. But if from the overhead tank through the siphon, it is possible to to make the water to flow from overhead tank to the field. See that siphon action, that is also the principle of physics as we know. See, therefore, here this figure shows from the water in the overhead beaker, the water comes. See, it may go up and come, that we know. Okay, once it started to siphon, automatically by the gravity it can move. See, therefore, in the agriculture and even sprinkler, the sprinkler or drip system, there are also physics. The sprinkler in that when water moves out of the hole of the sprinkler, it falls on that some part of that sprinkler that rotates, that makes the sprinkler to rotate through the spring system. Therefore, the theory of spring also comes into picture there. See another, see if our garden is there, we wanted to spray some medicine to the plants, there we are using some sprayer. See, there are also physics. See here, some liquid material is there. If I blow the air here, the water comes up and it moves towards this direction. See, that is on the basis of Bernoulli's principle. It works on the Bernoulli's theorem, Bernoulli's principle. As velocity increases, pressure decreases. If we blow the air, velocity in this region increases. As velocity increases, the pressure variation here, pressure decreases. Therefore, here atmospheric pressure remains the same. Therefore, water moves up and we may spray this liquid material to any plant. See, this may be explained through an experiment. See, if we visited any high school or elementary students for the interaction as the engineering teachers or PUC teachers, it is very important to meet the lower standard students for our interaction. See, during such a case, see, we may explain one experiment on this Bernoulli's theorem. See, it is a very easy experiment and very interesting experiment. See here, two thermocol balls we may select. Why I have to use thermocol ball means it is a lightweight, because of that reason. Or any lightweight balls we can hang like these two balls. Now I have to blow the air between these balls. Now question is, if I blow the air between these two balls, what happens to these two balls? Whether it goes away from each other, whether these two balls comes towards each other. If we ask this question, most of the students will tell that two balls go away from each other. I don't know whether if I ask with some of with you also, you may think like that, or I may once upon time I also thought like that. Ball may go away from each other, but no. Experimentally, you will observe if you blow the air, these two balls comes close to each other, and if the force of the blow is more, that hits each other. That is again on the basis of Bernoulli's theorem. As we blow the air, the velocity increases in between this as pressure decreases. Therefore, these two balls comes towards each other. See, this is a simple experiment the students may enjoy. Drinking any water liquid through the straw, atmospheric pressure and fluid dynamics comes into picture here. See, therefore, while drinking any cold drink through the straw, there also physics is there. You are not realizing it, but physics principle exists there also. See, again, not only this fluid dynamics comes because the density of this liquid, that is also important. Very denser cold drink is there, then we cannot pull through this straw, or if the diameter of the hole is very less, then again the denser liquid it will not come. Therefore, fluid dynamics also comes into picture, and the height of the length of the straw, that also very important. Then stethoscope, there also stethoscope uses the principle of multiple reflections to amplify the channel sound waves from a patient's body to the listener's ear. Here sound wave, or the conversion of this sound energy into the mechanical energy, and all these comes into picture. Physics exists there also. Yeah, again I will go to the kitchen. Gaslighters. Gaslighters work by using the piezoelectric effect, as we know, to generate a spark that ignites the gas. The piezoelectric effect converts the mechanical stress into the electrical signal. Here inside there is a piezoelectric material they are keeping. When we are apply the pressure, due to the piezoelectric effect, we may get the spark. See, we are discussing something about cryogenics. There is a gas liquefaction, about liquid nitrogen or liquid helium, but it is very for the students it is very difficult to understand that how that happens, because at low temperature it takes place, we cannot observe. See, actually in the nature itself, the water vapor is converted into water. Gas liquefaction involves cooling gas to a temperature below its boiling point so that it can be stored and transported into its liquid phase. Water can also change from a gas to a liquid when water vapor in the air loses energy. See, this is a water cycle. The rain, the cloud is converted. Cloud is actually the dense water vapor. That water vapor is converted into water at certain temperature. That therefore liquefaction of gases in there also the physics comes into picture. See this we can observe in the, see, if there is this idli cooker there, if we open the lid, you know, then water falls from the lid. See, there also what happens, water vapor is converted into water. Therefore liquefaction of gas takes place. See, this example we can explain for the students. If you go towards the game, again there is a physics. See, I taken the one example of shot put. See what all of the physics comes into picture there. See, force application and momentum. The shot putter exerts a force on the shot during the throw, imparting it with the momentum. The force applied is influenced by the strength of the athlete and the speed at which they can execute the throwing motion. Projectile motion. The shot follows the parabolic trajectory determined by initial velocity. See, this initial velocity is very important. For that reason, see, the thrower or the shot putter, he applies more force to increase the initial velocity, and angle of release also very important to increase the distance to which that moves. Therefore, the optimal angle for maximum range is typically 45 degree. Therefore, the movement of the hand is very important. See, therefore, see, in all time, the same thrower, he cannot throw for the same distance. Because of these reasons, there may be variation in the initial velocity. There may be small variation in this angle. And height of release, that is also very important for the range. Therefore, this range depends on initial velocity, angle of release, and height of release. See, therefore, taller athletes can release the shot from a higher point, increasing the range. Therefore, it becomes easy for the taller athletes to throw for the longer range. Friction and stability, that also comes into picture. Energy transformation, that also comes into picture during this process. See, same thing is there in the cricket also. A fast bowler, we know, he runs from the long distance and he comes, then he releases the ball, by which he can increase the speed. That is, his kinetic energy is transferred to the ball, and his motion of the his hand, that also comes into picture. See, there also physics comes into picture. A spin bowler, he spins, he rotates the ball, he applies some uh, which one tangential force to the ball. That tangential force makes the ball to spin. Therefore, there also physics comes into picture. I remember in my degree class there was one story in English that my teacher explained it very beautifully. There is actually the local cricket match. In that, one batsman hits one ball to the sky, means to the then there was a different types of field, since it is a local cricket team. A physics person is there, chemistry person is there, mechanical person is there, the carpenter is there, like this. A physics person, he stands and he tries to calculate its initial velocity, its moving velocity, at what time it can reach. See, all these are story, but still, see, as a physics person, he is thinking about the physics, when it will reach to my hand, what time it will take, and by which finally he may not take that catch. That is a different thing, but still he everyone, if there is a physics in mind, they can calculate like that. Then if we go towards the musical instruments, again acoustics and resonance comes into picture. Vibrations, resonance, standing waves, harmonics, pitch control, all these physics principles comes in these musical instruments. See, we know the basic of this music, that is sari gama pa da ni sa. What is the difference between the first sa and the last sa? Actually, that frequency doubles. The first frequency sa frequency and the last frequency sa. See, there also physics. See, here we know the tuning forks. Tuning fork comes with different frequency of 250, different range at 256 hertz, 288 hertz, 320 hertz, 341, 384, 432, 480, 512. See, therefore, see, if we compare this first one and the last one, see, 256 into 2, 512. See, therefore, this each frequency is with respect to one, this musical word sa, re, ga, ma, pa, da, ni. Again, the last sa, eighth sa, that is double the frequency of this. That is with the high rhythm. That is octave of the first one, octave of the starting sa. Therefore, in the musical instruments also, there is physics. Therefore, see, when we are discussing anything about sound wave, we can mention this. Any student who is interested in music, he can appreciate uh, the physics through this. Generally, the musicians or the music teachers, they are not mentioning anything about the physics. They are telling, however, the frequency is double or pitch is double, like this, like this. Then in the construction, bridges and buildings, again, bridges and buildings rely on basic principles of mechanics, stress and strain to maintain stability and safety. Mechanics comes into picture, and elasticity comes into picture. While constructing any building, the beams, columns, arches, trusses, see, everywhere the physics comes into picture. Any civil work, the base for that, that is, there is a physics. Any mechanical work, there is a base, physics base is there. Their material properties like elastic modules, stiffness, Poisson's ratio, all these comes into picture. Solar water heater. To reduce the energy loss, we need to use the solar energy. There also physics comes into picture. Solar water heaters work by using the sun's energy to heater, the solar energy into heat the water. The system consists of solar collectors that absorb the sunlight, a solar collector, solar panel, which is then converted into heat. This heat is transferred to the water through the conduction and convection. See, through this system, water flows. When this water flows, that heat is transferred to the water. That water flows. The heated water is stored in an insulated tank. For again, that insulation comes into picture. In passive systems, hot water rises naturally, while in active systems, a pump circulates the water. See, generally, in this solar system, that is um, pump is not needed. Hot water rises naturally. Here, if pump is needed, then we may use pump. Insulation helps minimize heat loss, and a thermostat ensures the water remains at the desired temperature. Overall, solar water heaters harness solar energy using principles of thermodynamics and heat transfer. Therefore, in the solar water heater, there is physics. Solar panels, photovoltaic effect and energy conversion, that comes into picture in the solar panel. In medical, X-ray machines, electromagnetic waves. Once X-ray is invented, after that, see, if any damage in the human body, it is possible to scan it through the X-ray machine. There, physics is there. MRI instrument, magnetic resonance and nuclear physics comes into picture. There are also physics principles which we are using. See, thus, I mentioned some of the items or some of the things where we are using this physics. Now, I wanted to talk something about the revolution of physics by which the modern electronics or modern computer, we may go up to quantum computers. See, quantum computer or artificial intelligence. There also physics is the base. That I am going to discuss in the future slides. Physics as base for electronics and computer. See, as we know, evolution of electronics through the invention of the electron, proton, etc., then vacuum tube, transistor, and integrated circuit. In 1883, Thomas Alva Edison discovered that electrons will flow from one metal conductor to another through vacuum, which is actually addition effect is known as. And in 1904, John Fleming applied addition effect in inventing two-element electron tube called vacuum diode. In 1906, following this, Lee De Forest developed a three-element tube called vacuum triode. This was the real beginning of electronics. See, actually, during that time, because of the Einstein's inventions, all these inventions are not focused much. But after that, this type of invention is focused. In 1927, Marconi invented radio, which was the primary form of education and entertainment. And in 1947, the transistor was invented by John Bardeen and co-scientists. This invention revolutionized the electronics industry due to its features such as lightweight, low cost, less power, reliability, etc., which reduced the size of electronic devices. See, previously vacuum radio was in use. After that, transistor radio can come into picture. When there is a vacuum tube, actually, I used a vacuum tube radio. In that vacuum tube radio, see, if you wanted to hear any information from the radio at 7:35, there is a Kannada Varta. If I wanted to hear at 7:35, I have to on that vacuum tube at 7:30 itself, vacuum tube radio at 7:30 itself. I have to wait for 5 minutes to start that vacuum tube radio. But once that transistor radio comes into picture, if I on the radio, immediately I can hear. And the size also decreased. The vacuum tube radio is not portable. Transistor radio came into picture. See, during that time, once a transistor radio came into picture, in every literature, Kadambari, Kannada Kadambari, I am having the habit of reading Kannada Kadambari, see, novels. In that during that around 1980s, they are mentioning, they are starting some story. ಅವನು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ರೇಡಿಯೋವನ್ನು ಕೇಳುತ್ತಾ ಕುಳಿತಿದ್ದ, like that they are starting. See, nowadays if anyone is writing the story, definitely they will start mobile ನೋಡುತ್ತಾ ಕುಳಿತಿದ್ದ. See, like that, that is a revolution. Another breakthrough happened in 1956 when Bell Laboratories invented thyristor, also called silicon controlled rectifier, SCR. In 1958, Jack Kilby, an engineer of Texas Instruments, demonstrated the first integrated circuits, IC. Large number of electronic components could be fabricated together on a single chip. Beginning of microelectronics revolution. From macro, we reached microelectronics. In the year 2000, Jack Kilby won the Nobel Prize in Physics for miniaturized electronic circuits. For this IC fabrication, he got the Nobel Prize. As the technology advanced, number of components fabricated on a single chip also increased. This advancement, chip fabrication, is accordingly called small scale, medium scale, large scale, very large scale, ultra large scale, etc. This resulted in the new era of computers, mobile phones, microprocessors, etc. Actually, see, 4-bit microprocessor was developed by Intel in 1971, microprocessor. See, therefore, if we go through this development, see, first generation vacuum tube, second generation transistor, third generation IC, small scale integration, medium scale, large scale, very large scale, ultra large scale. See, in the integrated circuit also, while fabricating the ICs, lot of physics and chemistry principle they are using. The lithography, photolithography, masking, etching, etc., etc. See, therefore, that we can, I put a slide with the name from sand to semiconductors. Most transistors are made from semiconductors, the materials at the backbone of the computer industry. Silicon has been material of choice for decades. Now, because it is abundant, 28% of the Earth's crust contains silicon and cheap to produce. See, therefore, different, see, it is literally extracted from sand, which is a silicon atom bonded with the 2 oxygen atoms, SiO2. Additionally, there is a convenient process for making parts of the material conducting or insulating by adding impurity atoms in a process called doping semiconductors, thus allowing precise control of the flow of electrons in a circuit. What speed of doping, that also we can explain. The process for transferring an image of a circuit.
ಮಧ್ಯಾಹ್ನ ಕಡ್ಡಾಡ್ಬೇಡ್ರಿ, ನಾಳೆ ಮ್ಯಾಚ್ ಐತಿ, ಓದ್ಕೊಂಡ್ ಕುಂದ್ರಿ, ಇನ್ನ ಹಾಲ್ ಟಿಕೆಟ್ ಬಂದಿಲ್ಲ. ನಂದು
Okay. Sorry for the some disturbance. Okay. See, physics in quantum computing. See, therefore, I'm talking about. I'm talking about the importance of quantum physics in day-to-day life. See, generally, as I said, students are thinking, why this quantum physics for an engineer? But now there is answer for this. See, due to that quantum physics, there is a quantum computer, development of quantum computer. See, superposition. A quantum bit can exist in multiple states simultaneously, both 0 and 1, rather than just one state at a time like classical bits or that digital bits. Entanglement. Qubits can be entangled, meaning a state of one qubit is directly related to the state of another, no matter how far apart they are. This enables a faster information processing. Quantum interference. The probability amplitudes of quantum states can interfere constructively or destructively, allowing certain computational paths to be enhanced while others are cancelled out. See, this quantum interference. See, there, see, this in IC fabrication from year 2000, according to Moore's law, every year the density doubles. The density goes on increasing, but he said around 2020 it will reach some stable value. After that, it is not possible because, see, for example, if there is a running track, total 8 tracks are there. To say the sportsman runs in that track, one in each track. If it in 8 tracks are there, 8 members are running. If it is 16, is 16, then very difficult to run. If I increase for 32, they can run, but they may interfere with each other. If I increase further, there is a possibility of interference with his leg only. That possibility is there. See, like that, we cannot increase the number of components in the small space because of the interference of the neighboring circuits nor neighboring rows. Then this quantum computer came into picture. The electron interferes with itself. That is the basic theory in quantum physics that we know. Quantum tunneling, wave particle duality, quantum measurement and collapse. When qubit is measured, its superposition collapses to one definite state, 0 or 1, which impacts the quantum algorithms and error correction. See, all these are the basic physics principle uh, which is used to develop this quantum computer. No cloning theorem. Quantum information cannot be copied exactly, which affects error correction techniques and quantum cryptography. Then role of physics in AI and ML. See, now in every engineering college, there is a branch of AI and ML, AIML, artificial intelligence and machine learning. See, there are also physics. PIML, physics informed machine learning. AI models integrate physical laws for better accuracy, like weather prediction, fluid dynamics, etc. Computational physics, artificial intelligence speed up simulations in quantum mechanics, astrophysics, and material science. Robotics uses physics for motion planning, stability, and reinforcement learning in simulations. Quantum computing, quantum mechanics enhances artificial intelligence efficiency, like quantum machine learning, computer vision and graphics, physical based lighting, shadows, and reflections improve artificial intelligence powered imaging, reinforcement learning in simulations, artificial agents learn in physics-based environments like self-driving cars, robotic control, etc. In astrophysics also, artificial intelligence comes into picture, helps to analyze cosmic data, detect exoplanets, and study black holes. Material science predicts material properties and optimizes chemical reactions, electromagnetism and signal processing. Artificial intelligence enhances wireless communication, medical imaging and radar systems, thermodynamics and energy optimization, reduces energy consumption in industries, power grids and data centers, etc. So many we can list the importance of physics in AI and ML. See, as we know, see, this is very important. What we are talking about artificial intelligence, for this one research paper, that is neural networks and physical systems with emergent collective computational abilities. This paper is the base. I don't know whether any artificial intelligence engineers there or not. But see, for this in 2024, means last year, Nobel Prize in Physics was awarded to John Hopfield and Geoffrey Hinton for their groundbreaking work in developing the foundations of artificial neural networks, which are considered the building blocks of modern machine learning and artificial intelligence. Therefore, base of the what we are artificial intelligence is physics. That is in the year 1982. This paper. See, this is the front page of that research paper. Neural networks and physical systems with emergent collective computational abilities. See, that is by J.J. Hopfield, Division of Chemistry and Biology, California Institute of Technology, Pasadena, California, and Bell Laboratories. See, this is in the January 15, 1982. This paper was published. See, therefore, with the full confidence, you may tell we are the base for the artificial intelligence. The physics persons are the base for the artificial intelligence. See, this is the effect of that paper. Computational properties of use of biological or organisms or the construction of computer can emerge as collective properties of systems having a large number of simple equivalent components or neurons. See, actually, on this basis, they have developed this artificial intelligence. Then I will mention a few natural phenomena in our daily life. I am not going in detail. See, rainbow, which is a refraction, reflection, and dispersion of light. Sound echoes, reflection of sound waves. Walking or running, as I already mentioned. Then tides, gravitational force, and fluid dynamics. Fog formation on glasses. You know, when we are driving the car in the morning, mainly during this season. See, there is a condensation and temperature difference. That is the physics principle. Fog formation on glasses. Wind patterns, atmospheric pressure and Coriolis effect, and lightning, electrostatics and electric discharge, etc., etc. So many we may list. Some of the things I listed here. Okay, that I tried to collect some informations in and around us which explains some physics principle or which works on the basis of physics principle, and that modern technology which this modern technology this developed, that is the what is the base of physics for this. If any queries, any questions, I will try to clarify it. Thank you all.
Good morning, sir.
Hello.
I am Dr. Savita Garg from East Point College. Hello, sir.
Madam.
Can you
Tell,
share
madam.
Can you share all the slides with us?
Yeah, I will hear.
Yes, sir.
Yes. Tell, madam.
Sir, can you share all the slides with me?
Okay, okay. I will share the slide. No problem.
Okay,
Hello,
sir.
good morning, sir.
Because
Hello.
Good morning, sir.
Good morning.
Sir, I am Shirin Mullah from SIET Bijapur.
Not clear, madam.
Yeah, sir. There are no inquiries and the explanation was very good. And I just want the PPT. Can you share this PPT in the WhatsApp group, sir?
Okay, I will share the PPT, the WhatsApp group. No problem. For all, I will make it available. No problem, madam.
More
thank you so
concepts
much, sir.
in 2 days.
Oh, madam.
We want to know more concepts, sir. Still more concepts we want to know in physics, sir.
Okay, full PPT I will share in the group. No problem.
Okay, okay. Thank you, sir. Very nice session it was.
Okay, thank you. Any other participants? Any query? Okay. From my side, I will thank all participants for patient hearing and for your queries. Thank you.
Thank you so much, sir, for an insightful and engaging session on unmasking the physics around us. Your deep knowledge, passion for the subject, and ability to relate physics to our everyday experience have truly enriched our understanding. We all sincerely appreciate the time and effort of Sir, who have taken to share his expertise with us today. I'm sure all the participants, both offline and online, have gained valuable insights that will inspire future curiosity and learning. On behalf of the organizing committee and all attendees, I extend my heartfelt gratitude to you, sir. We look forward to more such enlightening sessions in the future. So by this, we come to the end of FTP. Participants make a note. Feedback link that is shared in the WhatsApp group. Tomorrow's session subject is maths and the topic is graph theory for engineers, which will start sharp at 10 a.m. morning. I request all the participants to join with the shared link. Thank you one and all. Have a great day ahead. See you tomorrow.